Okay, that takes care of law of cosines when you're given when you're given one angle and you're given the two sides. So side, angle, side. The other situation where you want to use the law of cosines is when you're given all three sides of the triangle, but you're not told the measurement of any angle. So that's a side, side, side situation. And this example is right out of your book. And what they're doing is the scientists can use a set of footprints to calculate an organism's step angle, which is a measure of walking efficiency. The closer the step angle is to 180, the more efficiently the organism walked, which I thought was kind of interesting because it actually takes me a little longer to make a line with my 2 feet as opposed to walking slightly at a different angle. So this was kind of interesting to read. Alright, there's a diagram that they gave. You can see the 3 footprints. They labeled A, B, and C. And what they're trying to figure out is the angle between the steps. So what kind of angle is the animal making as I guess trying to walk forward. So in this example, we know all 3 sides. We can measure from one footprint to the other, and we can easily measure that. What we don't have available to us is the actual angle of angle B. When you go on, what is the angle B to tell us how the organism's walking? So all 3 sides are given. We don't know any angles, so law of sines is clearly out, because law of sines, you're going to need a relationship between a side and an angle, and we don't have any angles. The first example we did with the law of cosines doesn't apply because that gave us at least one angle. This one is given no angle, so it looks like it might be a little more interesting, but we're going to tie in what we learned last week about inverse cosines to finish this up. So our first step is, since we know the 3 sides, let's just plug it into the formula. That's very straightforward. So 316 squared, that's just one of the sides squared. The other 2 sides are being squared, the 155, the 197, minus 2, the 155, 197 show up again, and I'm doing the cosine of that b squared part, so we want the cosine of angle B. And if you notice the formula, we know everything there is to know about this triangle except for those angles, and this is going to help us get the angle. Alright, as I said in the last video, very easy to get tripped up on the arithmetic here. Strongly recommend you do it one little baby step at a time. So the first step, just let's take the 316, we're going to square that to get this number, to 99,856. We'll take the 155 squared and we're going to add it to the 197 squared to get the 62,000 number. And then finally just take the 2 times 155 times 197. That'll give us the 61,000 number here. And then I have the cosine of B. Now again, you can't put together these two 60,000 some odd numbers. You can't put those together because of the order of operations. So we need to isolate the cosine of B. So the way we're going to do that, we're going to subtract 62,000 from both sides to give us this value. Now we still want to get the cosine of B all by itself. It's like a variable. So we'll divide both sides by negative 61,070. Oh, I just noticed a mistake. That's not that value. So let's clean that up a little bit. That number should be, let's see, we have no, actually that's correct. That's correct because I subtracted 62,000 from both sides. Sorry about that. I was a little confused there myself. Okay, so this is the equation we have now. All I did was, just again, so you're not confused, I subtracted 62,834 from both sides, and that left me with the negative 61,000. To get cosine of B by itself, I'm going to divide both sides by negative 61,070. That'll isolate the B. That's like saying a 1 in front of it. So when I do that, I end up with the cosine of B is approximately negative 0.6. And all I did, that's just division, straightforward division right there. Okay, now at this point, this is where you might be stuck, and you're going to say, well, now what? I have this cosine of B. I have the cosine of an angle equals this ratio. How am I possibly going to get the angle? And that's where the inverse functions kick in. The inverse tells you if you know the ratio, you can back into the angle using the inverse. So let's see how we can do that on the graphing calculator. I know that this is the ratio. I am looking for the angle. So I don't want to use a cosine button because that assumes I know the angle. Right above it is the cosine to the -1 power. That's the inverse button. That's the one I want. So in this problem, we're going to do second, press the cosine button. That'll give me the inverse of the cosine. Now I'm going to type in what the ratio is. In this problem, the ratio is negative 0.60662. I will type that number in, negative 0.6062, close a parenthesis, and that is going to give me the angle that I want. And again, I'll just double check, make sure I'm in degree mode because I'm talking about degrees, and press enter. And the value of this angle is approximately 127.3 degrees. 127.3 degrees. And that is the value of this angle right here. And one more step, there we go. And the value of this angle is about 127. So this step right here is what I was doing on the calculator. I was taking the inverse of the ratio. The inverse of the ratio is going to give me the angle all by itself. Inverse of the cosine. And then that leaves me with the 127. So there you go. That's, if you know three sides, then you can back into finding the angle using the inverse cosine. All right. So that takes care of side angle side, 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 side. And there's just one more part to this, this whole unit, and that is a special formula that was developed a long time ago by Heron. Heron is the mathematician who developed this. And if you can see in this problem, they give us the lengths of three sides. And if we wanted to figure out the angles, we could use the law of cosine to figure out the angle, just like we did in the last problem, side, side, side. But in this problem, we're not interested in the angles. We're actually interested in the area between the streets here. So there's three streets that are intersecting. We're interested in the green part of it. So Heron, who lived a long time ago, he figured out there's a shortcut way of finding the area of a triangle if you don't know how tall it is. If you remember from geometry, you need to know the base and the height of a triangle to figure out the area of the triangle. In this problem, we have no idea what the height of the triangle is, and it doesn't look like we can get it pretty easily. So that's when Heron kicks in. He discovered that if you take half of the perimeter, so all the way around, if you take these three numbers and you add them up, you take half of that, you can use that in a formula to figure out the area. And the formula that he came up with, once you know half of the perimeter, you can use this formula right here to figure out the area of any triangle if you know the three sides. So pause the video at this point and record both of these equations. The first equation, the S equation, that stands for half of the perimeter. The second equation is the actual formula to determine the area of a triangle if you know three sides. Okay, good. Now that it's in your notebook, we can move on with this problem. And very straightforward. Now that you know Heron's formula, the steps are very straightforward. Step number one, all you want to do is figure out what half the perimeter is. So if you take the three sides, you add them up, divide by 2, you end up with 380 yards. That represents half of the perimeter. After you know half of the perimeter, you can go right into Heron's formula, and all you want to do is you take the 380, that's half the perimeter. You're going to take the 380 and you're going to subtract every side from the 380. So it's going to be 380 minus 170 times 380 minus the 240, and finally the 380 minus the 350. When you multiply that out in your calculator, and you're really careful about it with the parentheses, you'll get 18,300. The area of this triangle is 18,300 square yards. And that'll conclude it. Now, again, if you wanted these angles, if you were asked to find these angles, you could use the law of cosines for that purpose. But this purpose, Heron is almost like a side step here, since we're talking about side, side, side. You know, we're throwing in Heron's formula just to tie everything together for you. Okay, that covers the law of cosines.